Look, well, new life right there.
She's really cool. She is such a stickler on grading. And she's really
All right, are we ready to get started? This is it, last lecture. This is the last new information. What is it about this new information today that makes it unique as far as the final exam is concerned?
We can't be tested on Thursday.
That's right, this will not be on part one, what you learned today, but you have a pretty good idea that it will be on part two, which will be next Tuesday, a week from today. Don't forget, next Tuesday, a week from today, we're not meeting at 11, it's 11:30, not 11. Kyle, I didn't see you walk in. On your way out, make sure I get this to you, okay? Okay. All right, shame on me. All right, ready for week 14? All right, last. When's this homework due? If I forget to post the answers tonight, please someone remind me, because I want the answers there right away, because this could be on next Tuesday's final exam, what you're about to learn. So the assignment's already posted, but without the answers, but I want to get the answers up right away, even though you don't have to hand it in. We're using a new PowerPoint that I didn't really prepare much. I got it from the author of the book. As you can see, it looks different than mine, but you know, this is a subject I haven't taught in years. So, whoops, where'd it go? Where was I here? Boom. So you have the slides that are the most important we're going to go through today. The Excel confidence Excel spreadsheet's the same one from last week. So we're using the same spreadsheet. We're using the top part of it this time instead of the bottom. And then last day to hand in late assignments. You have till midnight tonight to hand in late assignments, unless it's week 13's assignment. That's normal. You have until midnight tomorrow to get 25% off. But anything before today's homework that was due, look and see if you got any zeros. And I want to tell you right now, I'm looking at a bunch of you who I know have at least a couple zeros each. So please, all you got to do is notice you have a zero, open the answer, handwrite the answers, not even the questions, the answers. And take a picture and get it in before midnight tonight. Turn the zeros into 40s. If you have 3 of them, it has a significant change in your grade. So 2 of them, 1 of them, but still, you never know. If your grade ends up falling right close to between 2 grades, you're gonna wish you changed those zeros into 40s. So please consider doing it. Again, I'm gonna remind you, Thursday at 11 a.m. is part 1, which right here, I can hand it out for you to look at now. And part 2 will be on Tuesday, which is here. And not any of it's on paper at all yet. Whatever that means. If you guys do really well in part 1, I'm gonna have to make part 2 so hard. No, I'm just kidding. Stop. All right, here's the new homework. 1, 2, what, you believe me? What? 1, 2, 3. 3 questions. That's all it is. And all we're talking about today are confidence intervals. Here's the deal. Because I knew it was the last lecture, I don't want to pile on a bunch of new information for you. We are going to learn how to manually calculate the confidence intervals, but this will not be on the final exam. We're going to learn how to use Excel to calculate the confidence intervals. This will be on part 2's exam. Everybody hear that? So it's going to be a pretty easy day, because this is a lot more work than that is. But you just need to know how it's done manually so you understand these, okay? Here's the deal, confidence intervals. Confidence intervals are all about that. Let's say you don't know the population mean, or you don't know the population proportion, but you're saying to somebody, hey, I know it's around this or this, and here's the deal. I'm gonna take a sample from that population, and I'll put together, here's the 3 most common confidence intervals, 90%, 95, 99% confidence interval. And what they mean is that when they take a sample, the sample mean is gonna be right here. And then they're going to go ahead and take a 90%, which will be, if you remember from the empirical rule, like what was it, 68% between 1 and 1 standard deviation, and 2 standard deviations, it took us to like, what, 96 or 97%, and 3 standard deviations would be like 99%. This will be the center 90%, which will be like from here to here. It will allow us to come up with 2 numbers on either side of that mean that the sample gave us. And those 2 numbers we then calculate on either side of that mean from the sample, we're able to say we have 90% confidence that the population mean is between these 2 numbers. That's what we're doing. We're trying to figure out a range of numbers that we can say with a certain amount of confidence, the population mean is in there. If it's really important, you're gonna use a 95% confidence. Now that takes it all the way to, let me think, what was the empirical rule? I can't remember, probably about the year, I guess, right around here. That takes it out a little farther. And so the numbers are gonna be a little wider, because then we're gonna say we have 95% confidence that this range that the sample gave us, somewhere in that range is the population's mean or proportion. And then if it's really important, that we definitely want to make sure that population number is in that range from that sample, we'll use 99% confidence, which takes us out to like here, right about here, here. So the numbers will be even wider, because we want to make sure that we're giving them a range that we know then the population's in there. And really what confidence intervals mean is that, let's say we're doing a 95% confidence interval, that if we ran samples from that population 100 times, 95 of them will include the population, true population mean in the range. The 5 of them will be so far off it may not include it, but 95 of them will include it. So, probability is huge in our favor from taking a sample, come up with a confidence interval that the population's in there somewhere. That's what this is all about. This is where you're starting 302 at. And I want you guys to walk into 302 and start learning something you already learned in 301, so that you're building confidence so you don't start feeling overwhelmed, because the homework's gonna be awful. And people start getting overwhelmed because it's so much harder than this course, because there's so much stuff you gotta do. Other than I'm just teaching you direct, here's what's gonna be on the test, here's what you need for the homework, here's how it's used, there we go. You got all this other stuff. So, here it is. What is confidence interval? Confidence interval, or an interval estimate, provides a range of values that, with a certain level of confidence, contains the population parameter, either the mean or proportion. It's so that we're coming up with a range from the sample we just took to make an assumption about the population with a certain amount of confidence. That's what we're doing. So now, here's the deal. There are 3 different formulas to do this, depending on what information you have. You can predict, you can do a confidence interval with one formula if you happen to know the population standard deviation. If you know the population standard deviation, it's given in the problem. If the problem states, and the population standard deviation is, then you can use the first formula, which is this formula, and you're using Z. Now, I'm not going to teach you this one today, the center one. This is if the population standard deviation is unknown, which, by the way, is the most common one. Then, when the population standard deviation is unknown, the problem will be giving you the sample standard deviation. And if it's giving you the sample standard deviation and asking you to get a confidence interval, you can't use Z, you gotta use T. We've never used T the whole semester. That's all part of 302. And it's when you're using just the sample information and you don't have any information from the population. That's when you gotta use a T chart instead of a Z chart. It's a little different. We're skipping this one today because I want you to learn the T chart in 302, not in the last lecture. I'm not gonna introduce you to something that we haven't even seen all semester. Proportions, which we've seen several times this semester, right towards the end here, we'll always use a calculation using Z, which is right here. Both of these are using Z in the calculation. This one uses T. I'm not teaching that today in the last lecture. All right? Now, when you take these manual formulas, turn them into Excel formulas, that first number is not like we did with quality control. Quality control was all about using however many standard errors we're going to use, and then we got to take that and turn it in and multiply it times 2 so it includes both tails. But with confidence intervals, the first number is always the opposite of the confidence interval percentage you're trying to get. If it's a 90%, that first number is 0.10. If you're doing a 95% confidence interval, that first number is 0.05. And now you tell me, if I'm doing a 99% confidence interval, what's that first number in here? 0.01. Very good. You get it. It's the opposite of whatever interval. Hey, I want a 75% interval. What's here? I want a 75% confidence interval. What's here? What's the opposite of 75%? 0.25. You get it. That's how you fill the first number for confidence intervals. It's the opposite of whatever the confidence interval. You don't have to multiply it times 2, nothing like that. You just 1 minus the confidence interval you're being asked to make. 90% would be a 0.10, blah, blah, blah. All right, you got this. Now, in the manual formula, this Z is very different than the first number in the confidence interval for Excel. This Z is something you gotta say, okay, I'm gonna lose some people here, so I'm gonna try this, I'm gonna try to take this slow. Are you ready? In the manual calculation, that Z is based on however much space is in one of the tails of the bell curve if you're doing a confidence interval. Let me give you an example. If I were doing a 90% confidence interval, that means there's 10% in the tails. But all confidence intervals are in the center of a bell curve around that sample mean or proportion. So the tails are the opposite of the 90%. So that would be 10%. But when we look it up on a Z chart, let me look it up on a Z chart. Let me show you the bell curve up here. The Z chart only gives us one direction. So we have to take the opposite of 90% and say, oh, then this tail must be 5%, because this tail would then be the other 5%. So we gotta look up Z at 5% to figure out what Z to use in the manual equation. Now, I lost some people right there. Are you ready? If you feel lost, I'm gonna do it again, but I need you to really focus on me. Here's the deal. They come up with that Z right there. This is the hardest part of manually, is coming up with that Z. Whatever confidence you're being told, like 90% confidence, you find the opposite of that, which is 10%. You split it in half, which is 5%. Then you look on the Z chart to see what Z would land at 5%. Let me repeat it a different way. To find that Z for this calculation, you take the opposite of the confidence, this time 95%. The opposite would be 5%. You split it in half, 2.5% and 2.5%. And then you go to your Z chart and you look up what Z lands at 2.5%. You ready? Let's look up 2.5%. All right, let's see. That's not even, follow my pointer. That's not even 1%. That's not even 1%. I'm not even 1%. Here's 1.07%. I'm trying to get to 2.5%. Here's 1.79. Here's 2.28. Here's, okay, I'm past 2.5%. Keep going this way. I'm trying to find, there it is. Look at my pointer, 2.5%. What is the Z?
1.9.
Negative 1.9, go up, 6, turn it into a positive. The Z you use is 1.96 for a 95% confidence interval manually. If you were doing it manually. That's the hardest part, is that Z. You can make it, because you gotta add and subtract. You gotta both add and subtract, so this only gives you the negative, so I just turned it into positive, meaning you don't necessarily use negative 1.96. You use 1.96 positive and negative because you're adding and subtracting. Let me do, here's the top, look at this is a weird one. 90%. So 10% would be the opposite. In each tail would be 5%. So now I'm gonna get as close as I can to 5%. But this doesn't have exactly 5%. I gotta scroll down. So I had to estimate. Oh, here we go. Look at, there's 4.95% and there's 5.05%. These two are exactly on either side of 5% right there. So if you look, negative 1.6, and then you go up, it's right between the 4 and the 5. Negative 1.64, negative 1.65, or negative 1.645, right in between the two of them. And that's the Z you use for 90% confidence. But you saw how I figured it out. I took the opposite, split it in half, tried to figure it out on the Z chart. One more, 99%. The opposite is 1%. So we gotta find half of 1%, which is 0.005. I don't think 005 is on here. Here's 0.0049, and here's 0.051. So it'd be right between these two right here. So I'm gonna leave my pointer there. Negative 2.57 negative 2.57 or negative 2.58, and here it is, negative 2.5. I would have put 7.5, but if we were to really do the number using Excel, it will end up being 2.576. Right between the two is the exact number. But what's nice is your PowerPoint gives you all of them for you right there. 95%, this is slide 13, because you know this is going to be on, oh no, you don't have to solve it manually. Why are you even taking notes? Anyway, 95%, 5% split in half means 2.5%, 1.96. 90%, 10% split in half is 5%, 1.645. 99% split in half is 0.5%, 2.575 or 76 is fine. So there's where those numbers come from. From there now, everything's easy. You can teach yourself this stuff. It's that easy from this point. I'm going to go to the first example. Go to slide 8. Here's our first example. No. Is it? That's not our first example. Where's our first example? Blah, blah, blah. Excel, confidence demo. 9. Slide 9. Is this at the bottom? If numerous sample sizes are taken. Here we go. A sample of 25 cereal boxes yields a weight of 1.02 pounds of cereal per box. Construct a 95% confidence interval for the mean for the weight of these cereal boxes. Assume that the weight is normally distributed with a standard deviation of 0.03. So you can see how this is done right here. First of all, we said 95% confidence. We looked on the Z-chart and we found 1.96 because we split the 5% in half. We looked up 2.5%. 1.96 is our Z. The standard deviation is given at 0.03 divided by the square root of 25. So you add 0.012 to 1.02 and you subtract 0.12 to 102. 1.008 is our lower interval number, and 1.032. So from our sample of how many? 25 boxes, we got 1.02 pounds, and we went ahead and found a confidence interval between 1.032 and 1.008. And we know that if we had time to find out the weight of every cereal box that's here, that it would be somewhere, we have 95% confidence that it will land between 1.008 and 1.032. That's what we just figured out, is that's what the confidence interval is. It gives you confidence that the population lands between them. All right, so now, I'm trying to remember if I did this one. No, we're doing 15. 14. Okay, so a sample of the 25 cereal boxes again. The sample gave us 1.02 pounds, standard deviation of 3. We did a 95% confidence interval and we were adding 0.012 to each one and subtracting 0.012. What happens if the standard deviation increased to 0.05? You do the math all over again. Now we're adding 0.020 instead of 0.012. The numbers around 1.02 widen. With a bigger standard deviation, the range of our confidence interval widens. This is preparing you for a multiple choice question. What happens if you're doing confidence intervals and the standard deviation increases? Does the interval shorten? Does it widen? Stay the same? Now, here it is again, the same 25 cereal boxes. Standard deviation was 3, and we did a 95% confidence interval. We got 0.012, but let's change the sample size. Instead of doing 25, we only did 16. We still want 95% confidence. What's going to happen to our interval? Shorten, widen, or stay the same? And sure enough, if you do the math on it, but this time square root of 16 instead of 25, you end up widening. Again, because the sample size went smaller, in order to stay 95% confidence, we had to widen the interval. The numbers had to be farther away. Now, in this time, we're going to go to a 99% confidence interval, still using our 3% standard deviation, still using 25 sample size, but look what happens. Instead of going 0.012 from 1.02, it's going now 0.015. Same thing takes place, widens. 3 reasons why we had to widen our interval. Because the standard deviation changed and went up, because the sample size went down, And because what happened here, the confidence interval went up, which would automatically widen it if you want more confidence. So those are the three things. That's what you need to be familiar is how each of these things affect the confidence interval if something were to change. There's my big hand. Where am I at here? We're gonna do another example. I'm gonna go in 31. All right, here's a proportion. Now it's a proportion, very similar formula, same formula you've been using the last couple of weeks. The proportion times 1 minus the proportion over the sample size square rooted. That gets multiplied times z and added and subtracted from the given proportion. So here we go. In a sample of 25 ultra green cars, 7 cars obtained 100 mile gallon. Hang on, that's not the one I want. Where is it? 33. 7 cars out of 25 got 100 miles per gallon or more. That's 28%. There's our sample size. Don't worry about testing if it meets the normal condition, if you have to use the whatever that factor is, because I will not trick you. The proportion times the sample size will be over 5. 1 minus the proportion times the sample size will also be over 5. You're going to you would use the plain equation right here. Nothing special has to be done. I'm not going to trick you. It's going to be that equation if this problem exists. What are the odds, right? So here it is manually. Then we'll do Excel. Manually, 0.28. The 28% our sample was 7 out of 25, which is 0.28. Plus and minus z. What percent confidence are we trying to find? It says, what percent confidence here? Is it 95? What's it, or 90? Let's see, it says find 90% confidence, then it says find 99. So we're going 90 and 95. So if it says 90, we're going to use a z of 1.645 that we found on the z chart. So sure enough, 1.645 times the square root of 0.28 times 1 minus 0.28 over 100. Here's our upper and lower control limit. 20.614 is our lower proportion. 35.386 is our upper proportion. How did we get this using Excel? Does anybody want to talk me through it? Should I just go for it? What's the proportion to start with? Equals 0. Is it 28? Is it 28? What is it? 28. 28 plus and minus. You got to do it twice. Confidence. What's the first number for this first problem we're doing? We used 1.645 because what kind of confidence were we doing? 90. So what's going to be the first number here?
0.1.
There you go, 0.10. Comma. Here we go. S, Q, R, T, parenthesis, 0.28, asterisk, parenthesis, 1 minus 0.28, parenthesis, comma. It's this whole thing without the sample size. The square root of the proportion times 1 minus the proportion without the sample size. The sample size is after the comma, and in this case, the sample size was 100. There it is. We'll do it real quick. Hang on. Hey. Here we go. Equals 0.28 plus CONFID, confidence. I'm just going to click on it right here. The first number is 0.10 because we're doing a 90% confidence, comma. Here it is, SQRT, parenthesis, 0.28, asterisk, parenthesis, 1 minus 0.28, parenthesis, gotta have 2 parentheses, almost forgot myself. And sample size was 100. If I did this right, the upper limit we got was, what was it? Shoot, hang on, before I hit enter, I wanna know if we did it right. 35.386, so 0.35386 if we did this right. 0.353854, there it is right there. This is the part you need to know for the exam, is to take a problem that's a story problem and turn it into the Excel equation and be able to get the result, both the positive and negative. Now, for me to get the lower control limit, all I'm gonna do to this equation is I'm just gonna take that plus, turn it into a minus, hit enter again, 0.206146, there you go. That's how easy it is. Now, let's get to the ultimate test to make sure you're with me. We're doing the homework. I'm gonna write the Excel equation for the number 1 right now. You've seen how to do it. Well, we didn't exactly cover this, but this is too easy anyway. We'll see it. Here we go. The average life expectancy of a Bostonian is 78.1 years. There's our center line. I can start right now. What is it, 78.1? Plus, minus, is it 78.1?
Yes.
Okay. Assume that the average was based on a sample of 50 Bostonians with a population standard deviation of 4.5. There's the key words, population standard deviation. If that would have said sample standard deviation, we couldn't use this. You've got to use T. That's where 302 is coming in. You will have questions that will not be giving you the population standard deviation, but giving you the sample standard deviation. That's the part you're going to focus on when you're in 302 is how to do the T part when you have a sample. But in this case, it says the population standard deviation is 4.5 years. So we already know right now that this center number is 4.5. There's that center number right there. Standard deviation 4.5, give an Excel equation and the result to find 90% confidence. So the first number, 0.10, the opposite of 90%, 0.10. And all we need is the sample size. This came from how many Bostonians? 50. There it is. Boy, that was easy homework. Let's go to number 2. Oh my God. Do you have to hand this in? Does this count?
No.
Oh, thank God. It's too easy. Jeez. Let's see. In order to estimate the mean 30-year fixed rate mortgage for a home loan in the United States, a random sample of 28, let's see, this is 5.25, but it's not given to us as a proportion, is it? It's not 0.0525. I gotta think about this. Do we have standard deviation? We do. So this is a mean. We're doing this one at the top. So let me get right here. Boom. We go here. What was the sample size right after start? It says a random estimate of 30-year fixed forward mortgage in the United States with a sample of 28. There's 28 is our sample size. Put a comma, put a comma. Sample size of 28. The average calculates is 5.25. 5.25 plus and minus confidence. All I need now is a standard deviation and what confidence are we doing? 5.25, it can be assumed the 30-year fixed mortgage rates are normally distributed with a standard deviation of 0.5%. 0.50. There's our standard deviation. Give the Excel equation and the result to find the 90 and the 99%. We would do this twice. The first time, the number would be the opposite of 90, 0.10, and the second time we do it, it's the opposite of 99, 99.01. There they both are. 90% and the 99% confidence interval for the 30-year fixed mortgage. 5.25 plus or minus confidence. Once we'll do it with 0.10 for 90%, 0.5 is your standard deviation, 28 is your sample size. Then we do it again, plus or minus, but that first number is 0.01, the opposite of 99%. Oh my God, this homework's too easy. Are we almost done with this class? I mean, we're so close. There's like one example left, I think. Oh, there's an in-class assignment? Does that count towards our grade? It does? Oh, we're not doing that. What are the cookies? Number 3, the last part of your homework. You want to try to do it on your own? No, we got the in-class. I guess you don't. You can do that now. Survey of 1,026. Is this a proportion? Fine. Let's see. 47%. Here we go. We're down here. Hang on. Let me just erase some of these. Let me get all set up here. Here we go. Here we go. This is a proportion. It says a survey of 1,026 people. So let's jump right down here. 1,026 is our sample size. That's pretty big. Survey of 1,026 people asked, what would you do with an unexpected tax refund? 47% response said they would pay off debt. 47. So this is 0.47. This is 0.47. Asterisk 1 minus 0.47. Parenthesis, parenthesis. All we need now is what is our confidence interval. Give the Excel equation result to find the 95% confidence interval. Here we go. 0.05. The opposite of 95% confidence interval. for the population proportion of the people that would say pay off debts with the unexpected tax refund. Too easy? Can we do this on the exam?
Yeah.
Who said no? Well, you just walked in, that's why.
No, I just went to one of my notes.
Oh. You wanna see one more?
No, not for that, he just should have turned off his hand.
Oh, you don't wanna see one more?
No,
Okay, you wanna do the in-class?
we have an in-class? I thought you said Thursday was the last one.
No, we have one more today.
Oh, I feel like you should be nice, it should be like our Christmas present, early Christmas present, and we should actually do it. You should give
Really?
everyone 100, that way everyone can get 100.
You know what's crazy is I just handed back last week's in-class assignment, and since I did a non-detailed grading, I think almost everybody got 100. Because I did a non-detailed grading. Notice I said almost, not everyone. There's someone still had missing items somehow or another. Does anybody want to see one more? We got time to do one more. You do? Do we want to do a proportion though, or we want to do a mean with the standard deviation?
Mean.
Mean? Okay, let's find with a mean. Hang on, I was not prepared to do another one, so I gotta figure this out. Let's open up the book, we'll just go straight to the problem. Yeah, this is class, but we got tons of time, it's only 1:45. What are you talking about? But you think she was gonna talk you out of a new class? Where's the book? Where's the book though? The book is disappeared. It's usually right there, and now it's gone.
The degree.
Well, I lost the book. It just completely disappeared. Am I in the wrong thing? No, it's right there. The book is gone. How crazy is that? Let me turn this off for a second. Go in, maybe it's in my, that'd be great. No, how can the book disappear? So I can't even go through another exam. That book has disappeared. That is the craziest thing I've ever seen. I don't know how that ever happened. I need that book. Alright, so I've got nothing. Let me see if there's another example in the PowerPoint.
Let me tell you a thing or two.
Oh, here we go.
I heard about that.
Yeah, I found an example on the PowerPoint.
You notice here that he's like working on it.
Okay, here we go. Here we go. Here's an example. What?
I have a question.
Yes.
For the exam, like, is it gonna be 2 grades or just 1?
One grade. Yeah. So I'm not handing back the first part when you come to take the second part, because I gotta combine
It's
it.
gonna be on the exam.
All right. By the way, anybody who came in late, please stop by and pick up your, I didn't get to hand back your assignment if you came in late. Here it is. Here's an example. IQ tests are approximately normally distributed with a standard deviation of 15. A sample of 22 employees give a sample mean of 106. Compute, we're just gonna do the 90%, the 90%. Instead on the board, let's do it with Excel. Oh, I can't because then you won't be able to see the PowerPoint. Unless, can I put this over here like that and put the Excel up on the other side? Hang on, let's see if I can do this. Look at this. All right, let's do it right here. Equals. Anybody want to talk me through this? Anybody feel like they got this? They feel? What'd you say? What'd you say? You wanted to do it? What'd you say? Okay, here we go. Hang on, he's gonna talk me through it. Here we go. What's the first time? What's the center line? 106 plus CON. I'm just gonna click on the word confidence, which is right. Where is it? I gotta type more letters. Confidence. Okay, alpha. What will be our alpha for? We're doing the 90%, so 0.10, comma. What next?
Standard deviation
Standard deviation 15, comma, what next?
Sample size 22.
10, sample size 22. Here we go. The upper control limit from 106 is going to be 111.26. Here, let's go to the next slide and see if we got it right. Hang on. 100, where is this, the 90? The 90 says 100.74. What did we get? Oh no, the upper. 111.26, which is exactly what we got. Now let's do the lower by changing this to a minus. And if we did it right, it should be 100.74. 100.74. Gosh, this is too easy. Let's make the whole exam these. I know, they're that easy, aren't they? I know. So let's look around here. I want to see what else I got here. Oh my God, you guys, you almost